Before moving on to the next question, notice one thing. That is here. So yeah, there should be a beta up here. So the change in variable should be beta mgxsq. There'll be a factor down below, factor here, a factor there. That's a beta factor down here. Right. So if we do that, we have beta factor down here to the power. That being said, we move to the next problem, that is D. And now we have to, let's see what we have to do. Small it down. Better, more convenient for me. So D, express the average height of the lid as an appropriate derivative of the logarithm of the partition function and use the partition function calculated in C to find delta x. So you have to find the average height of the lid denoted by this average, and that is nothing but x dx dx. If we move to the phase space, this would be p here, yeah, and this would be probability of that depends on p and q. Right. Now, notice one thing, that is the probability is given by a to the power minus beta e divided by zs with some appropriate factors up front. Right. Actually, this thing is normalized, so we don't need to worry about these factors. So this is that, and we plug in the quantities. Please note one thing, that is this p is basically p1x, p2, p1y, p1z, and also p2x, p2y, and it goes on to pnx, pny, pnz. Same for q. I mean, there should also be the one for lid, right? Similarly for this thing. So if that's the case, and if we are allowed to break it down, then we'll have Zn dependent on x x e to the power minus beta right? Now notice this z and x, this thing does not contain mg or f, right? This thing does not have f, but this h to the power minus something 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 has mg or f in it. And if we differentiate this thing, the x comes down. So basically follow this thing. Zs is basically z and to the power minus beta mgx. Let's take this thing to be f, then dpl dx. Now if we differentiate this thing z with respect to f, then what happens is this thing comes out, beta f factor minus beta f factor times beta x comes down, the rest remains the same. Now we take beta on the other side, right? So this is what's at the numerator here, right? But x average has, let's call it u, capital U, way. So this x average has this zs down there. How do you get this thing? Well, consider this thing, ddf of ln zs. Now zs comes out also minus beta, and we have lzs by table, and this is basically up zs. So this is basically this quantity. So x average is minus 1 by beta ddf on zs. Now we know what zs is. We've seen it before. We copy paste it for convenience. But let's do it again. Sorry for the inconvenience, but I need to get a hang of it. Um, yeah, so ZS is given here, and if we differentiate it, so we have to take the logarithm of this thing. If we take that, this, all this, so we have some factor that does not contain f, and after taking logarithm, what happens is this minus n plus 1 on f, and then we differentiate this thing, minus n plus 1 by f, and we multiply by beta. So delta x, sorry, average x average comes up to be n plus 1 divided by beta f. Right? So that's that.